Math is the basis of our society, and one cannot normally live in our present day and age without knowing how to use the basics. We use it to pay rent, evaluate which discount on a sale is a better deal, and count how many days are left until vacation. Without math, there could be no scientific progress at all, and we would still live in a prehistoric world. Statistics in particular are a notion everyone is familiar with. Take newspapers, for instance, which are more often than not covered in graphs and filled with numbers such as dates or percentages. We tend to value and trust these numbers, which then allows us to form our own opinions. However, we regularly notice that some of these numbers are false, misinterpreted, or they contradict themselves. For example, three brands of toothpaste, Sensodyne, Oral-B, and Colgate all claim that their product was the most recommended by scientists, which created a controversy and many memes on the internet. But another more severe mistake due to misuse of statistics was the case of Sally Clark, a British woman who was accused in 1998 of having killed two of her children when they were still infants. A professor and consultant pediatrician was called to testify that the probability of two children in the same family dying from SIDS was about 1 in 73 million, which is extremely low. So SIDS, or sudden infant death syndrome, is the sudden unexplained death of a child less than 1 year of age. A child is diagnosed with SIDS even after a thorough autopsy. No other cause of death is found, which explains why Sally Clark's innocence was so doubted. However, the professor didn't take genetic factors into account. Therefore, the 1 in 73 million probability was actually way too low. Indeed, if one child in a family dies from SIDS, it means that other members of the family are also more likely to die from the same cause. But let's just say that the professor was right. There are then three possibilities. 1. The two kids died from SIDS. 2. The two kids were killed by their mother. And 3. Other possibilities, like, for example, one homicide and one of SIDS. So these three possibilities are all extremely unlikely, and the first hypothesis is not less valid than the second when you look at the percentage of mothers murdering their own children. However, the prosecutor managed to convince the judge and public opinion, which resulted in 3 years of imprisonment for Sally Clark, who was released in January 2003 when exculpatory evidence was found. However, she wasn't able to recover from this incident and developed many serious psychiatric problems, including alcohol dependency, and she died in 2007 from alcohol poisoning. This is one example, but there are many ways to misuse statistics, including to deceive people. For example, according to these graphs, more iPhones means more people die from falling down the stairs. Going to see a sports match will make you lose weight, or visiting Orlando's After Adventure will increase car sales. If you just look at the first one, you might think that the reason why people are dying from falling down the stairs is because they're looking at their phones too much. But maybe it's because the sample population the study was based on had steeper steps, or it could also just be a coincidence. Therefore, no conclusion can be found from just looking at these graphs. This can be summed up by using simple variables x and y. Let's say that falling down the stairs and dying is x, and buying more iPhones is y. There are then four possibilities. 1. X causes y. 2. Y causes x. 3. A third variable z affects both x and y. For example, scientific progress makes buildings higher and higher, which calls for longer and deadlier stairs, as well as more cell phones. And 4. X and y are completely unrelated and it's a coincidence. The lesson to be learned here is that one cannot draw conclusions just from looking at the evolution of two values. Graph manipulation is also a way to manipulate public opinion. For example, here you can see two graphs of the same data, but you don't draw the same conclusions from both. From looking at the first graph, it looks like the difference between each year is enormous, but in reality, the difference isn't all that large. And this effect is produced because the first graph doesn't start from zero, which is extremely misleading. But does that mean we can't use statistics at all? What can or can't we believe? Statistics are actually very useful, and even as engineers, we will be needing to study it. It allows us to make more or less accurate predictions, which can be crucial for the launching of a project, or even for voting for presidents or programs. Without any data, our decisions are only based on our own limited feelings and experiences, and therefore we have a higher chance of making bad choices. All we have to do is to look at the data critically before drawing any conclusions. Ironically enough, A study has shown that most people don't actually read the information that is written on graphs and just look at the shape. And if we prevent ourselves from doing so, we become less gullible and it's less easy to manipulate us in the realm of our own capabilities. Indeed, sometimes the data is just a huge lie, and we have very few ways of proving that they're fake by ourselves until someone else does it for us. The numbers can very well be manipulated, like what the Chinese government is doing with the current crisis. But there is nothing that we as individuals can do about that, apart from relying on other sources and keep checking for conflicting evidence.